day, everyone. Today I'm going to speak to you about the nomenclature of electronegative substituents. So we'll first start off with alcohols and amines. So if you have some linear structure, let's say, and you have an amine group that's hanging off of there, whether it be branched or right off the terminal end, you're going to have to label it as, so if I were to just kind of imagine this not being there, this NH2 group not being there, I would say that would just be propane, right? But if that's the main functional group about the whole compound, then we're going to write propane amine. So we scratched off the E that was going to be originally at the end of propane and added am, ine as the suffix. Okay. So nothing terribly complicated about that. Okay, so there could be another example where you could have isopropylamine. That's just kind of a common term or a trivial name. Let's say we have this amine, so this is going to be butane. Okay, so again, we're just dealing with a linear alkyl chain that's saturated as a main chain. And then 2 amine. All right, so going to be at the lowest locator number, which is going to be 2. We were to account for the stereochemistry, amine is going to be the first. So it would go 1, 2, 3. But as it's depicted here, we want that to be flipped over into the front. And remember that the hydrogen that would be assumed sticking out in the front would go to the back where it needs to be. So our top 3 would be in the front. So that would go, so as it's depicted right here, it's going R, so it would be S, 2-butane, 2-amine. Or sorry, S-butan, 2-amine. Okay. All right, so let's think of, alcohols. So we've covered amines, just basic. Representations here. So let's go with alcohols. Oh, another thing that should be mentioned about amines, that if the amino group isn't the highest order electronegative substituent, then it would be amino, sort of like amino acids, right? So that's a good way for you to think about it. Carboxylic acids are going to be higher order, or higher priority, if you will. So, a carboxylic acid, as you'll see later on in this module, is actually in our chapter F, if you will, as well. It's going to be a higher order substituent relative to an amine. Okay, so it would be, for instance, if we were to say this were, and I'm just gonna ignore the stereochemistry because we have a little bit to cover here. Okay, so this is going to be 1, 2, 3, 4. So I would say this would be 2-amino butanoic acid. So we'll get into carboxylic acids in a little bit here. But I just wanted to say that if this isn't the highest priority, then it's going to be amino, not amine on the end. Okay. Or part of the main chain group. All right, now on to alcohols. So alcohols are always going to have that suffix of OL. So in other words, if we had this right here, this would be 1-propanol, right? Okay, so you'd shave off the E and then tack on that OL, and it would definitely leave you with little ambiguity, right? Okay, so you can see some of the list of different prefixes and suffixes. So this would be a prefix, this would be a suffix in table E1. So just be sure to look over those. You'll have them at your disposal during test and quiz time. I'm not going to give you any hugely elaborate structures. I just want to make sure that you get your stereochemistry right, you get the right numbering, and all the rest should really just fall into place, okay, if you're paying attention. All right, so let's see here. So if you have so notice that with an alcohol, you don't have you have this suffix, or you have the suffix of OL, but if it were not the main group, we'll say, like for instance with our friend butanoic acid. So if we were to functionalize butanoic acid, we had OH here. That OH would be 3-hydroxy. So sometimes you'll hear about OH as being a hydroxyl group. So it'll just be 3-hydroxy butanoic acid. Okay. Now, again, that's when it's in lower priority. When it's in first priority, then you're going to put it OL because it's part of that root system. Okay, so the differences between hydroxyl is that hydroxyl group or alcohol is going to be terminal in its nature, right? It's going to dead end at that OH. Whereas with an amine, you can have a secondary amine, you can have a primary amine, you can even have a tertiary amine. Okay, so with that said, when you have certain things branching off, you need to label them as such. So, for instance, in your text or in your notes here, I have this thing's dying on me. Ooh. So soon. Okay, so we have butanamine here. Okay, so sort of like what I have here, except it's in the one position, and then we have 2 methyls attached. Okay, so those 2 methyls you would put N, N dimethyl butan 1 amine. So this locator number is just to tell you where that particular amino group is branching off, and that NN is going to tell you, again, those methyl groups are going to be directly attached to the N group, or the amino as it is. Okay, so I made a note in your notes here. So think about highest to lowest priorities. Alcohols are going to be number 1, followed by amines, which are going to be number 2, and then all the other stuff like ethers, all the other things you've learned up to this point. So ethers, halo, and nitro group. So you would essentially just put those in alphabetical order, but those are going to be third to, these 2. And then we'll get into some carbonyl-containing species and nitriles as well when we get further on into the submodule here. Okay, so here's some multifunctional mixed examples, if you will. So let's go with the easiest one first here. So we have an ether group. So remember, that's going to be lower priority than this amine. So in other words, this is going to be kind of mentioned off of this particular molecule that's or this particular carbon rather, that's connecting these 2 functional groups, right? So this would just be methane because you just have 1. Okay, remember you need to shave off that E at the end of methane. And you just have an amine. So an amine is going to be higher priority than an ester, or sorry, an ether rather. So it's going to be methanamine. Okay. And then you're going to have a T-butyl group with that oxygen there. So it's going to be what? A T-butoxy methanamine. Again, you're not going to have any specificity because you don't have any locator numbers because you're just dealing with one sole center carbon, right? So in other words, it should be tert or T-butoxy methanamine is your compound there. Okay, so let's take a gander here at the problem at the top. Okay, so we have NH2, which is going to be higher priority than our nitro group, which is right there on the bottom. Okay, so we want to use this as the top locator number. So we go 1, 2, 3, because we want to have our lowest locator numbers, right? We don't want to go all the way to, 5? Yeah. So, in other words, keep it short and sweet. And we are going to have to think about a ring with respect to stereochemistry here. So we're going to have a tiebreaker to beat things out on the right as opposed to on the left. Right, so we have a chain of 3 methylene carbons here. And then we have just one methylene removed from a nitro group branching off. Okay, so we're going to have cyclohexane as the root. So cyclohexane 1 amine. Okay, because it's in there in the first branch, or first position branch. Okay. Then we have that nitro group at the 3 position. So we'll put 3 nitro, 3 hyphen nitro. Okay. But we also have RS configurations there. So we need to figure out what those are. So this is going to be first priority by default. We're going to have second priority here, third priority here. Okay, so as it's depicted, we're going to go with R. But since that's in the back, we have to flip it around. It needs to be wedged out, so it's going to be S. So it's going to be 1S. Okay, and then 3, we don't have to flip anything over. This side's going to be higher priority, so it's going to go 1, 2, 3. So that's also going to be S, so we'll put 3S. Okay, so 1S, 3S, 3 nitro, cyclohexane, 1 amine for the particular branching side for the amine. Okay, last one. When we talk about priorities here, OH or alcohol is going to be the highest priority, followed by NH2, followed by this chloro group. So, in other words, it should be 1, 2, 3. Okay, so that means that we should have a suffix of OL, we should have a prefix of amino, and a prefix of chloro here. So let's, so if we were to do 1, 2, 3, 4, that would be a butanol, right? So we have butane, scratch the E and add OL, okay? E9 all, E9 all, yeah. All right, so we have a stereo center right there, okay? So we're gonna put, 4 amino, since we're looking for alphabetical order here, 3 chloro, butanol. But 3 is going to be stereo specific. Chloro is going to be top priority. Next is going to be this methylene amino. So that's going to be tiebreaker from what's over here. So it's going to go 1, 2, 3. Now, again, we need to have that flipped out onto the outside. So as we see it, it's going to be R, but since we have to flip it, it's going to be S. Okay, so it's going to be S, 4-amino, 3-chlorobutanol. Okay, so moving on to aldehydes and ketones. Do that real quick. Aldehydes and ketones are actually much easier than you might imagine. Because, you have Al for, so aldehydes. And then ketones. Okay, so I underscored the ONE, underscored the AL for aldehydes. Okay, so now we need to figure out what the prefix is. Well, the prefix is going to be the same for both, which makes it very convenient. So remember, the aldehydes are always going to be terminal, and ketones are always going to be, within a particular cycle or a particular linear chain. Okay, but if aldehydes or ketones are branched, then they're going to have a different type of naming system. Okay, so if something's branched off, like an aldehyde, it should be referred to as a carboxaldehyde. Okay, so branched are, so this should be, if it's main, it should be Al. Okay, so that's a suffix. If it's not a main substituent, then it's going to be oxo. And then if it's off as a branch, it should be carboxaldehyde. So that means if it's just a aldehyde hanging off of some linear, more elaborate chain that has other stuff, it's higher order. Okay. But remember that if these are higher order than, or higher priority with respect to OH groups or amino groups, that means that they're going to be part of the main chain. So you must count, CO-1 carbon. Okay, so be sure to factor that into your numbering scheme, etc. Okay, so let's take a look at a couple of the compounds that I have drawn out or drafted in your notes. Okay, so we have a phenyl ring. Okay, so the longest contiguous carbon chain here is going to be 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Then this phenyl group is going to hang right off of this 4-position carbon. Remember that this is going to be a branched ring, so you would refer to this as phenyl. So it would be 4-phenyl. And then it would be pentanal, because again, you're shaving off that E and adding Al. Okay, so is that it? No, of course not. You also have that phenyl there, which is on a stereogenic carbon. So if we were to think about it in terms of highest priority, phenyl is going to be 1, followed by this carbon, number 3 in the chain, and then number 5 on the chain where the methyl is. So it's going to go 1, 2, 3. So it's going to be R. Okay. All right, so let's look at this funky looking thing, and then we can move on. So there's an aldehyde as well as a carboxylic acid. Or sorry, not carboxylic acid. Ketone. Okay, so Al is still going to factor in. So pentanal, 1, 2, 3, 4, 5. Remember, you still want to count where the ketone is going to be. Okay, so the ketone is going to be oxo. This is going to be oxo. And ONE if it was part of the main chain and it wasn't superseded by something else. But in this case, aldehyde is going to take precedence. So it would be 1, 2, 3. Okay, so going right to left. So pentanal. Okay. 3-oxo. Okay. Now, I also kind of wedged this aldehyde outward. So in other words, this is going to be first priority, second priority. No, remember we need to do a tiebreaker. So in other words, it's going to go 1, 2, 3. So in other words, it should be S. Okay, so it would be S, 2-ethyl, 3-oxo pentanal. So we'll kind of tie everything up in the end when we go over the integrated examples here. But let's get into some carboxylic acids and their derivatives. Okay, so now we're going to dive into Interchapter F, or where the highest priority examples exist. So these are all going to be nitrile all the way up to carboxylic acids. If you want to take a look at table F1, that's going to have all the suffixes and prefixes you're going to need. Okay, so all the above mentioned have their carbons as part of the main chain locator. So you're going to have your carboxylic acids as the highest priority, followed by acetic anhydrides. And esters is third. So acetic anhydrides and esters I'm just going to generically go over. I'm not going to go into deep detail with them. Acid chlorides probably as well. Amides and maybe nitriles, but nitriles aren't such a big deal. It's really that just to get yourself familiar with some of the nomenclature conventions here. So, like RNS configuration priority, the highest atomic weight atoms take precedence. So, carboxylic acid over amide, acid chloride over nitrile. Okay. But let's also think about things that branch off, right? So, I alluded to having carboxy. Ooh, this thing's going dead here. Carboxy substituents are things that are hanging off as terminal functional groups. So in other words, carboxylic acids are carboxaldehyde, carbonitrile, carboxamide. Okay, so some of these things are going to hang off, sort of like how you would see as lower level, but anything that's a carboxylic acid itself is actually going to be part of the main chain. Okay. So we'll just go over some examples here in a little bit. But let's just kind of quickly go over esters. So esters, so for instance, you've seen ethyl, which would just be this side, acetate, which would be on the left side here. So so you're going to have alkyl alkanoate nomenclature, right? So in other words, if you let's say if you had phenyl benzoate, that would look something like this. So you had benzoic acid, and then a phenyl group directly attached to it. Okay, so that would be phenyl benzoate. Okay, so the ATE is to give you the impression that's referring to that sort of carboxylic acid faux-ish kind of moiety that's hanging out over here that has the carbonyl. That's the ATE or 8 part of the nomenclature, and the YL is going to be anything that's directly attached, singly bound to that oxygen there. Okay, and then acid anhydrides, which are even slightly more obscure. So acid anhydrides are simply, if you were to, let's say, fuse two carboxylic acids together and, like condense them into one, right? So in other words, something like this, so you're going to have symmetric and then maybe some asymmetric ones. This would be a symmetric acid anhydride, which would be acetic anhydride. So this is an acetylating agent. Okay. And then there's, so let's say if you had benzoic pentanoic anhydride, that's going to be an asymmetric anhydride. So benzoic, one, two, three, four, five, pentanoic anhydride. Okay, so pentanoic acid would be on the right here, benzoic acid would be on the left. So that would be benzoic, pentanoic anhydride. Okay, so this OIC suffix is something you would place for, let's say, butanoic acid or pentanoic acid. So that OIC is going to be pretty indicative of any type of carboxylic acid, if you can imagine. You could also think of, let's say, acid chloride. So let's say I use this a lot in graduate school. Heptanyl chloride. Okay, so that OYL. So you scratch off the E off of whatever alkyl chain that you have and replace it with that OYL and then chloride. That's going to be your acid chloride nomenclature. So 1, 2, 3, 5, 6, 7. Put the carbonyl there. and then the Cl directly attached. So if you don't know already, these are going to be highly reactive species. You would keep those in an ampule or something to make sure that no atmospheric moisture reacted with them, because this would react out with water and then form carboxylic acid. One other thing, if you have multiple acid moieties, or CH2, or sorry, CO2H moieties branching off of something, if you have multiple ones, you would have, let's say if you had a linear chain, you would say it's dioic whatever acid. Okay, so let's go over some sort of multi-layered examples and see if we can try to sort of clarify some of these higher or lower priority substituents, especially electronegative ones. So again, I would kind of bookmark that table on page 504 in your text, that table F1 for reference. All right, so the first example I'm going to go over with you is this amine and alcohol kind of mixture of, combination within one compound. So pentane, which is going to be the longest main chain, so we'll put 1, 2, 4, 5. Okay, 1-ol, so that oxygen is going to be, or that OH group is just going to be hanging off the end. 5-amino, so that means it's going to be hanging off the other end. So we're going to name or number this 1, 2, 3, 4, 5. We have trimethyl. Okay, so we don't have any indicated stereochemistry here, so we can just put 1 here, 1 here, and 1 here. Okay, so and that's going to be some not symmetrical, but you're going to have 2, 3, 4 trimethyl throughout the whole thing. So you're just going to have a branch off of each carbon. Okay, so for part D, so that was an easy one. If we have hexane as the main structure, so 1, 2, 3, 4, 5, 6. Let's choose this to be number 1, so we'll put that OH right there. We have an amino group, which is going to be right here at the 4 position. Okay, and then we have 2 ethyl groups, so we'll put diethyl right here. And our longest chain is going to be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So we're good. Yeah. So this is going to be 3. It's going to be 4. It's going to be 1. Okay, 5, 6. Pretty straightforward. Okay, so the next one we'll look at is nitrile substituents about a root structure. So this is also going to be a name to structure exercise. Just pause. Okay, so on to nitriles. It's not F17. It's going to be F.21. Same page, 513. Okay, so again, this is going to be a name to compound exercise. So we have hexane dinitrile. Seems so simple, you almost think there's an error or something. Okay, so we're going to have a count of 6 carbons that are contiguous. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. Now, if it's a dinitrile, that means there are 2 nitrile groups. Remember that nitriles are always going to be terminal. Okay, so in other words, those carbons that are part of that nitro group are going to be part of the carbon count in the main chain. So in other words, you're going to have 2 terminal ends, just some linear chain without any branches. and just double-ended nitrile groups. Okay, so for B, we have heptane nitrile. So notice how you don't scratch out the E, you just leave it there and then add nitrile at the end for a main chain. So heptane nitrile is going to look like so. 1, 2, 3, 4, 5, 6, 7. Very good. I can count. Okay. There's my nitro group. That should be treated as the 1 position. So it's going to go 1, 2, 3, 4. So if it's S4 nitro, we're going to put the nitro group right here. Kind of bunched up. So if we're thinking about along the lines of tiebreakers, we have 2 methylene groups and then C triple bond end. So that means C is technically singly bound to nitrogen 3 times. So it's going to be the tiebreaker to this methyl group of the other side. So in other words, if we want it to be S would have to go in this particular fashion, right? So in other words, this nitro group is going to have to stick out. So I'm going to have to wedge this thing sticking outward. Okay, so it's going to go 1, 2nd priority, 3rd priority. So going in a sinister, devilish way. Okay, for C, so you have 4,4-diethyl cyclohexane carbonitrile. Alrighty, so we have a cyclohexane, which is our root. Okay, and then we have a carbonitrile, so that means it's going to come off of the... I'm not drawing that totally accurately. Remember that these are going to be linear compounds. So it's really going to stick straight down. Per the Vesper model, it's going to be 180 degrees. All right, and then 4,4-diethyl. So it looks something like that. Okay. So 1, 2, 3, 4. So it's going to be 1,4 relationship between the ethyl groups and the carbonitrile. All right. Last thing we're going to look over is pretty much all the functional groups integrated in the structure. So problem F.32 on page 514. So pause for a minute and I'll put that up for you. All right, so to wrap up the last few examples we have here, some of the higher order stuff. Okay, we have a nitrile and then 2 amides here. So if we're looking for the lowest count, we're probably going to have to go sort of clockwise, if you will, around this linear chain. So we're going to go 1, 2, 3, 4, 5. And there's going to be 6. Okay, so in other words, the count is going to be hexane. So hexane is going to be the main root. But since we have amides, not 1 but 2, it's going to be a diamide. Okay. And then we have what is referred to for a nitrile is actually going to be a cyano group, right? So cyano is going to be a prefix. So it would be 3-cyano. And this is going to have a stereo center, but hey, book wasn't sweating those details, so I don't think we are either. There's no dash or wedge. Okay, so what do we have over here to the right? We have cyclohexane as a main chain, so we can kind of go with that. So cyclohexane. Okay. Now, the carboxylic acid moiety is going to be sort of the number one or highest priority, so we would label this as 1. Doesn't really matter which side we go, it's going to be symmetric on both sides. So it'll be, what is it, 3,5-dioxo. Yeah. So remember that each one of those ketones is going to be represented as oxo. So it'll be 3, 5 hyphen dioxo. Okay. And then cyclohexane, and then 1 carboxylic acid. Okay, so that 1 carboxylic acid is represented as a suffix, or as a suffix, or end, if you will, because it's actually that 1 carbon that's branching directly off of that junction. And again, this is going to be first priority. Okay, so this one's going to be a little bit less straightforward. You have an amide, which is going to be the highest priority, followed by your alcohol, and then also a phenyl ring. Okay, so you're going to have an amide as your main chain, so it's going to be 1, 2, 3, 4. So bute, but we have an alkene, so we're going to put bute 2-ene amide. Okay, and we're going to have a 4-hydroxy, right? Okay, and then N-phenyl. Remember, it's going to be a large italicized N. So when you have something that's branched off an amine or an amide, and it's secondary or tertiary like that, it's not part of the root main structure, you need to put N hyphen and then whatever's going to be hanging off of it. Or if there are 2 identical things, you could put N comma N dimethyl or N comma N diphenyl. There was a second one there, right? So N-phenyl. Okay, bute 2-ene amide, sorry. Okay, and then you're going to have what? E for opposite. At least opposite in German. Okay, so that's pretty much it. Okay, so no other stereochemistry really to account for. All right, so then the last thing we have here is this little funky looking bugger. Remember that carboxylic acid is going to be the highest priority. So we have 2 amide groups that are actually hanging off of a main chain. So this is going to be 1, this is going to be 2, and this is going to be 3 carbon. Okay. Now, these 2 are going to be hanging off like branches. Okay. So in other words, these are what are referred to as carbamoyl when they're branched off amides like that. So that amyl is the giveaway there. Okay. So if there's not 1 but 2 amyl groups, that means it's going to be diamyl. Okay, kind of a mouthful there. Okay, so we have propanoic acid. So we have 1, 2, 3. So propanoic acid is the main chain. And then just 2, 3 diamoyl. propanoic acid. All right, pretty straightforward. Hope that was quick and to the point. And that's pretty much it for nomenclature. Yeehaw! All right, take it easy. Bye.